Alright, this video is to help you understand how to graph radical expressions. A radical expression is just a square root expression, or essentially y equals the square root of x is about as simple a radical expression as you can have. The only real operation in there is taking the square root of whatever input values you choose. The best input values to probably pick are going to be the perfect squares. And the reason for that is, if we choose numbers like 0, 1, 4, and 9, when I insert 0 in for x, again, the square root of 0 is just 0. Again, if I change that to be a 1, the square root of 1 is 1. And if we change that to be either 4 or 9, well, the square root of 4, again, inserting it underneath that square root, is 2, and the square root of 9 is 3. Again, if we pick other numbers like 6 or 7, or just things that aren't perfect squares, you can still find their square roots using a calculator, but they're much more simple to find and much more easily graphable if we can get them on the table. And in that case, then we can plot our points at 0, 0, 1, 1, 4, 2, and 9, 3. And if we connect those dots with a smooth line, technically, we could have found larger numbers, such as the square root of 10 or 16 or 20. However, realize we cannot find the square root of -1 or -2 or really anything left of the y-axis. Our domain, remember the possible x values that provide real answers, is that x needs to be greater than or equal to 0. I can't take the square root of negative numbers. So those easy answers, again, came from the perfect squares. And the only answers come from the fact that x is a positive number or 0. As long as that's the case, we can also talk about the range. If we can only plug in positive values, notice that our green line started at 0, 0 when y had a value at 0, and all of the remaining y values happen above that point. So the range is also that y is greater than or equal to 0. Now that's a basic parent function. That's as simple a function as we can have with the square root. So what happens if instead there's more going on? What do I do about x minus 4 being underneath that square root, and then following the square root we'll add 6? Well, I can't just plug in 0, 1, 4, and 9. Not if I want easy answers anyway. 0 especially, 0 minus 4 is -4. I can't take the square root of that number to begin with. So I'm going to be guessing at throwing in numbers and not really coming up with anything usable. So instead, I don't want to guess at that stuff. Instead, what I'm going to do is think about what number can I plug in to possibly get me these nice numbers. And let's start with 0. That's the best place to begin. What could I plug in that -4 will give me 0? And I know that that number is positive 4. Positive 4 minus 4 is 0. The square root of 0 would be 0, and then I can add 6, and I get a nice simple answer of 4, 6. Now I also know that number used to be my 0, which means it used to be my starting value, which means that's a really good point to have to begin with. All of my other numbers just need to stay positive, and really if I plugged in anything like 3 or 2 or even 3.9, these numbers are going to become negative. So I know that I want numbers that are definitely, thinking about my domain, to the right of or greater than or equal to 4. But again, if h in my formula down here at the bottom is a 4, right, x minus 4, then the best place to start is going to be at positive 4. Since all of my numbers essentially then are just plus 4, I'm going to take 1 plus 4 and call it 5, 4 plus 4 and call it 8, and 9 plus 4 and call it 13. Those will be my new easy points. 5 minus 4 would have been 1. The square root of 1 plus 6 gives me 7. And notice we'll start to get a nice pattern here as well. Plugging in 8. 8 minus 4 is 4. Square root of 4 is 2. Plus 6 is 8. And notice 6, 7, 8 happening for our pattern. Now the same thing goes for 13. If you plug it in up top, you'll end up with 9. Which means I get my nice answers of 5, 7 up here. Then I'll get 8, 8. And unfortunately 13, 9 is a little off my graph, but you'll notice that it would have been on my line, my nice curve, my square root, my sort of half a parabola going up and to the right. And in that case, that means everything is above 6, and y would be greater than or equal to 6. Those ideas of how to come up with your good, easy points also hearken to transformations. And we know about these transformations. Again, that h value inside is a horizontal shift. That's the reason all of my points were right about 4 units. X minus h tells me move everything right to h. My good starting point is going to be at h. Again, if that would have been a plus sign, if it was x plus h, essentially I'm thinking about negative numbers. That's actually going to move me to the left. Vertical shifting, again, that's that k value. We started up at 6 because k was 6. A vertical reflection would happen if we were multiplying out in front by a -1. And a vertical stretch or shrink would happen, again, if we were multiplying by a number out in front other than 1. Let's apply those ideas. Go ahead and take a second. Think about the 3 graphs over here at the left. How would those transformations apply to these 3 functions? I'm going to go ahead and let you fill in what you think they are. I'm going to fill in all the data, then I'll come back and talk about that. So go ahead and pause the video now and attempt to graph all 3 of those functions over here on the graph at the right. Okay, I've got all the answers filled in here for you. So you'll notice first I drew the black line in. Again, that was my good 1, 1, 4, 2, 9, 3, and of course starting at 0, 0. You'll notice that the green line starts from the same place. We'll start all the way at the bottom here. The green line was the 1/4 multiplied by the square root of x. The square root of x is still good for all perfect squares, so I didn't really need to use different numbers. 0, 1, 4, and 9 were good. What you'll notice though is once I got all my answers of 1, 2, 3, I had to multiply them all by 1/4. While the first answer at 0, 0 square rooted is 0, multiplied by 1/4 is still 0. So we didn't shift anywhere. But you'll notice all of my other numbers were multiplied by 1/4. So 1 became 1/4. My y value up here at 2 became 1/2. And up at 3 became 3/4. It became a very flat line. It was what we call a vertical shrink. And you've got that vertical, sorry, that V got a little messy there, vertical shrink by 1/4. Anything where we're multiplying is either going to be a shrink or a stretch. If you multiply by something like 1/4, things get smaller. Now the other 2 are both shifts. Again, if you add or subtract on the outside of a function, such as the blue one up here, we've shifted all of our black points up here, this black line, down 6 units. So essentially it became this blue line down here, starting at -6, and then we went up and right 1, and up and right 3, and up and right 5. We've got that nice 1, 3, 5, 7 pattern going on. And then, of course, the red line, because we're subtracting inside of our function, that's a horizontal shift. And again, subtraction takes you to the right. +3 would have made this a 0 underneath the square root. So +3 is going to be my old 0. Everything moved to the right 3 units. And I get that nice red line going on. And again, all domains and ranges are given there. Key to those is find your starting point, such as the red point here. I started at 3 in the x values, 0 in the y values, and I traveled to the right, and I traveled up. So everything's greater than or equal to. I hope that helps you with graphing square roots, graphing radical functions. If you have any questions, make sure you see your teacher. Otherwise, good luck, and as always, have fun.